All right, Stover back. Let's see how far we can get. I have a limited period of time here. My classes start at 7:46, so we're going to talk about VSEPR theory. And VSEPR theory really, and I'm going to erase this, so you might want to either jot it down or take a screenshot. VSEPR theory is all about predicting the structure or shape of a molecule. It's all about predicting the structure or the shape of a molecule. And really, that is done through Lewis structures, right? Once you draw your Lewis structure, then you have a grounds, a basis to predict the shape. And if you look up here, valence shell, that deals with O. If you look up here, valence shell, that deals with the outer electrons in the outermost shell. And remember the octet rule, every atom besides hydrogen and helium, and sometimes some exceptions with like boron and other ones, want 8 electrons in their valence shell when they bond. And if you notice this, electron pair, and one thing you know about electrons, especially if they're paired, there's 2 negatives, and so 2 negatives will do what when they get close to each other, or 2 positives. 2 positives or 2 negatives. So like repels each other. So this one will go this way when they get close, and this one will go this way when they get close. As they move this way to each other, they push each other away, just shoot each other out, because they have that magnetic kind of attraction. You take that end of a magnet and that end of a magnet, and it's going to push each other back. It's not going to attract. Like repels, unlike attracts. Okay? So remember that. So we have valence shell, outermost electron pairs, 2, and it's talking about repulsion. Oh, let's do that again. Take that back. It's repelling each other. So what that's saying is, when you get 2 atoms together, and they have these electrons swirling about in like the cloud, right? This atom comes over here. This one is going to push against this electron. It's going to push, and it's going to push it into a certain shape. Does that make sense? So it's going to help in the shape because those electrons are going to push against each other, and kind of form them into a shape. And we'll see that in just a minute. But that's basically what valence shell electron pair repulsion is doing. It's predicting the structure and shape of a molecule based on where the electrons are and how much they're going to repel each other. Okay? So again, it's predicting the structure and shape of a molecule, and it's doing that by predicting how the electron pairs in both of those atoms, or 3 of those atoms, or 4 of those atoms, are going to push against each other in order to push those atoms or molecules into a specific region or shape. So let's do that. Let's go. So I'm erasing it now. That is basically what VSEPR is. Okay? I'm going to try to get rid of this. Actually, I'm just going to get rid of this. Boom, like this. And rewrite. Valence shell electron pair repulsion. Okay, so let's go back over Lewis rules. When you're going to draw a Lewis structure, number 1, you identify your atoms, which ones, okay? Then you count their valence electrons. Then you draw a skeletal structure. Then you place remaining place the valence electrons around the outside atoms. Then the electrons that remain, you put remaining on central. And if need be, to get your full 8 electrons, you do single or double or triple bonds. This represents 2 electrons. This represents 4 electrons. This represents 6 electrons. You don't see much of the triple bonding. You will in some of this, but yeah, that's the basic gist of it. So these are your valence or your Lewis structure rules. I'm going to erase that so that we have room to go through our VSEPR rules. All right, so our VSEPR rules. Our VSEPR rules are pretty simple too. Number 1, you draw Lewis dot structure, LDS, okay? Then you count the regions, spaces, places of electron density. That basically means where they are bonding, or where there's lone pairs. And a lone pair just simply means 2 little electrons floating around by themselves without being bonded to anything, okay? So you count those, you look for those high density areas, those regions of high density of electrons after your Lewis structure. Then you just simply identify the most probable. Remember, science is about probability. Probable shape of the molecule based on the electron pair repulsions, and then you determine the positions of the atoms. Determine the position of atoms, and that's it. Pretty simple. So you draw the structure, you count the regions, you identify the most probable shape of the molecule, you determine the position, and then you do your best to draw it out. This is difficult. That's where you get these weird little things in chemistry where you have this atom with this thing happening, and then you have this going like this, right out like that, and then you have this and this. So you have all these like that. It looks kind of like 3D like that. That's the purpose of it. So those are the rules. And now let me give you, before we jump in, this might be the last thing we do. Basically, let me give you the different types of basic template structures, okay? So let me just say this. Number 1, you have linear. Give me a second. Linear. Linear model. I'm going to make sure I'm giving you this correct here. Valence chart. Trying to find one that I can share with you. And I don't have one in my box. Okay, so let me just give it to you. Linear. A linear model is a structure that has 1 to 2, okay, on the bonding areas. So you have this right here, atom right here, then you have it bonded to 2. And it's in a line linear, okay? It's a linear. Pretty simple. Its degree is going to be 180. That's pretty simple. okay? So that is a linear structure, okay? And it's going to be difficult for me to even draw these, okay? So let me just tell you that right off the bat. The next thing you're going to have is a trigonal planar. Trigonal planar. I know these are ridiculous. Trigonal planar. You see the word tri in there. That's pretty simple. That means that you have, whereas up here you had 2, this is going to have 3. Okay, so you have your central atom, right? And then you have 3. You have 3 bonding angles off of it. 3. Okay, this is called a trigonal planar. Pretty simple. And that bond angle, boom, boom, is going to be 120. And the reason why that is because these electrons are making it to where each of them have their own comfortable place. And so up here, it's most comfortable to be 180 degrees apart. Here, it's most comfortable for them to be 120 degrees apart. Now, you can tell, like, as you get more and add more of these atoms to molecules, then you could tell that it's going to be a little, the degrees are going to shrink up a little bit, okay? Because you can't, no matter how much you want to be apart, if you're in a large room and there's a lot of people, you can't be alone, okay? If there was only 3 of you guys, you could spread out, you know? But here, there's going to be more and more, and we'll see the difference there. So let's go to the next one. In chemistry, you have this word, this prefix, tetra, which means 4. So this is going to be tetrahedral. Tetrahedral. Okay, so just remember that. I know these are weird, okay? But in tetra, 4 means simply this, like you had 3 up here. And so here you're going to have 4. So you have 1 atom in the center. You have a central atom. You have 1, and then you have kind of like 1 coming out. And then you have 1 in the back. And then you have 1 like off the top specifically. So then you have your atoms bonded, okay? And you can kind of tell that that's sort of 3D, even though I suck as a drawer or as a person that draws. So you have those basic shapes as far as the first 3, linear, tetrahedral, linear, tetrahedral, and trigonal planar. Let's do a really odd one. Oh, I didn't give you the degrees. So the degrees between these are going to be, what do you think they're going to be? You basically have no clue, and you shouldn't. This is going to be 109.5. 109.5. Okay? You have a tricky one here, which is going to be called the bent model. And it's basically just as it says. A bent model is going to be either 2 or 5, but we're just going to draw a 2 here, where the electrons, all of these, none of these have no lone electrons in these, okay? There's no lone electrons here. No lone electrons. Now, a bent shape does, and I'll show you what that does to it. So basically, a bent shape is a central atom with 2 or 4, but I'm just going to put 2. I'm going to put two lone electrons here, okay? And then you have bonds, which we would normally draw straight in a Lewis structure, but since these electrons are here, they're going to be pushing this bond this way, and this one's going to be pushing this bond this way. And so your shape, which would be linear, is now bent. And the bent molecule is going to have basically either a 104 to 107. It's kind of iffy, okay? They don't really know how much it's going to bend. But these are some of your basic ones. Then we're going to get into 5. It's 742. So what I'm going to do is I'm going to stop this. I'm going to come back, and then we're going to take these shapes, and we're going to put about 2 more shapes on and their degrees, and then we're going to draw them out and see how they work, okay? So hopefully this helps so far, and we're going to get back to it in just a few.